Hi, and welcome to CoulScience. I'm James Coulter, and this is the first video in a series of lessons which will introduce you to how to name and write chemical formulas for different chemicals. The first 7 lessons serve as the foundations for basic chemistry, which is known as inorganic chemistry. This will teach you most of the chemical naming systems for things you'd run into in a chemistry class. This information is generally taught in grade 9 and 10 sciences. But if you're new to chemistry or miss some concepts, these videos should help clarify your understanding. Once you're comfortable with naming and writing chemical formulas for inorganic chemicals, you can move on to more advanced rules and nomenclature, and you'll end up redefining what is required to make something qualify as an acid, an ionic compound, or a molecular compound. I formed these videos after years of teaching, and have found this progression of topics to be the best way to develop a stronger understanding of nomenclature. The first 4 lessons will introduce you to what are usually considered grade 9 topics in many provinces and states in North America. I do want to emphasize that it's important that you follow the lessons in progression and avoid rushing ahead. You have to form a solid foundation in the early topics if you're going to progress in chemistry. With that concept in mind, let's start with classifying chemicals. The periodic table is a list of every type of atom that can be used as building blocks to make chemicals. We call these building blocks the elements. The atoms can't be broken down into smaller chemicals, but can be combined to form an unlimited number of different chemicals called compounds. Notice that sometimes 2 letters were assigned as the symbol for an element. When this is done, the first letter is always capitalized, and the second letter is always written as a lowercase letter. So the symbol for silicon is always written as capital S and lowercase I. I want to introduce you to a boundary highlighted in this video in red. The zigzag pattern shown here is commonly referred to as the staircase. It's not shown on every periodic table, so it's good to memorize where it's located. The staircase separates the metals found to the bottom left and to the left of the staircase from the nonmetals, which are found to the right. You'll also notice that hydrogen sits all by itself up at the top left. It's a nonmetal with unusual characteristics, and so it sits all alone up on the top left. So let's clarify. What's the difference between an element and a compound? An element is any chemical which is only made up of one type of atom found in the periodic table. The gas oxygen, for example, is made up of 2 atoms of oxygen. That's just one type of atom, so this chemical is classified as an element. In contrast, a compound is a chemical which is made up of 2 or more different types of atoms. Carbon dioxide, for example, is made up of 1 atom of carbon and 2 atoms of oxygen. But what happens if oxygen combines with a different element? Well, if it combines with hydrogen, then it can form water. What's even more interesting is that the plants have figured out how to reassemble a bunch of particles of water and carbon dioxide, breaking and remaking bonds between carbon, oxygen, and hydrogen to form a much more complex structure called sugar. There's really no limit to the number of unique combinations of atoms that can form, leading to a universe of diverse chemicals. So, if you're given a chemical equation, how do you know if it's an element or a compound? Simple. If there's only one symbol for an atom showing, then it's an element. Take a moment and look at these chemicals. Which of them is an element and which are compounds? The first chemical has 2 symbols, Ba and O, so it's a compound, not an element. The next one, Fe, is 1 symbol. It's the symbol for iron. 1 symbol, so this is an element. What about CO2? 2 different elements, carbon and oxygen, so it's a compound, not an element. Finally, XeF6. It also has 2 symbols, Xe for xenon and F for fluorine. Conclusion? It's a compound, not an element. So for the entire set, there's one element and 3 compounds. This tree shows you how we categorize chemicals. We'll expand this in later videos, but at this point, you now should understand how to distinguish between chemicals and at the first branch, elements versus compounds. There's no subcategories for elements, so for that branch of chemicals, my hope is that you've mastered identifying them already after this lesson we've just gone over. Now, what's left for us to do is learn how to distinguish among the 3 different categories of compounds: molecular compounds, ionic compounds, and acids. So let's look at compounds. There are 3 categories of compounds: acids, ionic compounds, and molecular compounds. Each of these compounds is made of 2 or more different elements. To figure out which kind of compound your chemical is, you have to look at what elements are present. For most of the chemicals you start out learning, you should be able to classify the chemicals based on the first element. So for the moment, we'll turn all of the atoms at the end of the formulas into a generic X. Now, look at the first element. If it's a hydrogen, then the chemical is going to be an acid. If, on the other hand, the chemical is composed of a metal as the first element, then the chemical is going to be an ionic compound, also known as a salt. Finally, if the chemical is composed of a nonmetal, along with another nonmetal, then the chemical is going to be classified as a molecular compound. The rules I'm giving you right now are a bit generalized, but you will find that it'll help you to start recognizing patterns. As you get more familiar with the different types of chemicals, you'll find on occasion that these rules will be broken. But until you get the idea of writing formulas and become more familiar with compounds, these rules will work well for you. It helps to visually link this to the periodic table. So let's look at this diagram. If the first element is hydrogen, found at the top left of the periodic table, the chemical is usually an acid. If the first element is a metal, found below and to the left of the staircase, then the chemical is likely to be an ionic compound, represented by an I in this diagram. Finally, if the element is a nonmetal, the first element is a nonmetal in the compound. This will be found on the right of the staircase. Then you can assume that the chemical is likely to be a molecular compound. So let's try to apply this. The first chemical here has a chemical formula of Mg3P2. How do we start? Well, we look at the first element, which is, in this case, magnesium with the symbol Mg. Let's find where it appears on the periodic table. Magnesium is number 12. That's on the far left, 3 rows down. So since that element is found on the bottom left in the green region, then AIM, the first element in this chemical, appears in the I section, which makes it an ionic compound. Next, we'll look at this chemical, TeCl2. Te is the first element. We look around on the periodic table and we can find it at number 52. That's in the blue section on the right. It's the 5th row down, number 52. That makes it M, a molecular compound. Now let's look at CrO. The first element has the symbol Cr, which is chromium. This is found on the periodic table at number 24. This is in the section I, so this chemical is an ionic compound. Next one, P4. What's the first element? Well, wait a minute. There's only one chemical symbol here, so this chemical isn't a compound at all. It's just an element. Watch out for this. I have a number of students who forget this and then try to name the chemical like a compound and end up losing marks. One more, HClO3. The first element has the symbol H. On this table, H has the element was the element that's at the top left. It's right now covered up by the A. So this chemical is an acid. Okay, so so now it's time to practice. In a moment, I'll ask you to pause the video to try a set of practice problems. Take a moment to grab a piece of paper and a pencil. I'd like you to form 4 columns, one for elements, one for acids, one for ionic compounds, and one for molecular compounds. Then I want you to sort the chemicals on the left of the screen into the different categories. Don't try to do the problems in your head. Do them in order, one at a time in sequence. Record them into your list, and using the periodic table on the right to help. And remember, AIM. Hydrogen is any chemical starting with a hydrogen is an acid. Anything that's a metal on the bottom portion is, to the left is an ionic compound. Anything to the right is a molecular compound. Now pause the video and try it. When you're finished, resume the lesson to review your answers. Pause it now. Well, if you've resumed, I'm assuming that you've already tried the problems. So hopefully you weren't caught by any of these ones. These are the 3 elements in the list: fluorine, nitrogen, and barium. There are 3 chemicals which are listed which are ionic compounds: calcium bromide, CaBr2, copper-2 nitride, which is Cu3N2, and magnesium chloride, MgCl2. There are 6 chemicals which are listed which are molecular: C3H8, SO3, Pi5, C2O2, N5O8, and finally As2Br4. There are only 2 chemicals which are listed which are acids: hydrobromic acid, which is HBr, and hydrofluoric acid, HF. So congratulations, you've learned the foundations of how to distinguish among the majority of chemicals. Remember, first identify if the chemical is an element or a compound. If it's a compound, remember you must first aim, AIM, to classify the chemical before trying to name it. The rules that have been presented to you in this lesson are simplified for learning purposes. There are chemicals that break away from these rules, but this lesson provides enough of a foundation that you can move forward. As you progress with chemistry and become more comfortable with the concepts, you'll be able to transition to dealing with more complicated concepts and learn more detailed rules. You now have the ability to classify chemicals as an element, an acid, an ionic compound, or a molecular compound. I now recommend that you continue on to my second video, writing chemical formulas for elements. I welcome you to provide feedback and comments to help me improve in the delivery of quality online lessons. I hope you enjoyed the video.